Okay, these are the chapter 2.1 notes, the rectangular coordinate system and graphs. So these notes will go pretty quick. I'm assuming a lot of this is a review for you still. It's kind of nice to have that reminder if this is stuff that you have not been doing for a while. Top of every set of notes, you will see this box. This is the box that was cut right out of the homework. This should match the homework for this section. Okay. Some of the notes are super organized and those objectives are listed within the notes. Sometimes they're not. This one's fairly straightforward, so we're not going to worry about that. When we graph, we have the x-axis. The x-axis is our horizontal axis. You'll notice here, this is labeled as the x-axis. Our vertical axis is our y-axis. There will be times that you are graphing in terms of t and h. Rare occasions we swap the x and y axis. That should be painfully obvious if that is happening here. X is always the horizontal line and y is always the vertical. We have the origin. The origin is that single point where those two axes cross. The origin has the coordinates 0, 0, and as we start graphing, everything starts at the origin. Additionally, our Cartesian coordinate plane is separated into 4 quadrants. We start in the top right with the first quadrant. There our x-coordinate is positive and our y-coordinate is positive. Quadrants are numbered counterclockwise, so second quadrant is our top left. Third quadrant is our bottom left, and the fourth quadrant is our bottom right. It is important to put that together and know what those ordered pairs are going to look like. In the first quadrant, both our x-coordinate and our y-coordinate will be positive. Anytime you see an ordered pair with 2 positive coordinates, we know we're in the first quadrant. Our second quadrant, our x-coordinate will be negative, our y will be positive. In quadrant 3, the x is negative and the y is negative. And in quadrant 4, that x-coordinate is positive, that y-coordinate is negative. Take a minute to process that later this semester. It's going to be really helpful if that is intuitive for you, if that comes pretty quick. Okay. Down here, every time we plot a point, it is called an ordered pair. That's because the order matters. We've got a pair of numbers wrapped in those parentheses. The order matters. That first coordinate, the x-coordinate, always tells us our horizontal displacement, how much we're going to the left and to the right. That second coordinate, our y-coordinate, is our vertical displacement, how much we go up and down. Anytime we are graphing on a rectangular grid, it is important to make sure that everybody is following along. So if there are no numbers in there, please go ahead and write them in. There is the occasional place where I've numbered them or I pulled a coordinate grid that has numbers and the numbers don't match. Cross out and let me know what you are counting by. Okay, it's got to be painfully obvious why we're putting the points where we are. So point A is at the coordinates -2, 4. That -2 is our horizontal displacement. So we're going to go 2 to the left in the negative direction. The +4 is our vertical. So 4 in the positive vertical direction, 4 up. So 2 to the left, 4 up. That puts point A right here at -2, 4. Point B, +4, -2. That means we go 4 to the right in the positive horizontal direction, 2 down in that negative vertical direction. And there is point B, +4, -2. Point C, -3, 0, that means 3 to the left. That first coordinate is our horizontal displacement, 0 up and down. So here is our point C, -3, 0. D is at 0, -3, so we have 0 horizontal displacement and a 3 negative vertical, so down 3, and there is my point D, 0, negative 3. A is at negative 3, negative 1. Both of the coordinates are negative. We would expect that to fall into quadrant 3. So we're going to go 1, 2, 3 to the left, 1 down, and we get E right here at negative 3, negative 1. Review at the bottom of function notation. We are pretty comfortable with that Y notation. Been using that for a while. If I plug in a number for X, I'm going to get a number for Y. So here it says X equals 10. Plug that in, we multiply it by 2.5, we get Y equals 25. That means when X is 10, Y is 25. There's the ordered pair that goes with that equation. A little less comfortable with function notation. Sometimes it's nice to have a formal name for a function, especially if we are working with multiple functions. I don't want Y equals 17 when X equals 4 in one function, and then Y equals negative 2 when X equals 4 in another. It gets a little confusing. So with function notation, the X that we are plugging in is actually part of that equation statement. So here, if we plug in X equals 10, I've got F parentheses 10. We're going to read that F of 10, which equals 2.5 times 10. Again, we get 25. It was the exact same function, right? And we can say F of 10 equals 25, or write it this way. F of 10 equals 25, which means when I plug in 10 for X, I get 25 for Y.